Welcome to lesson 3C1. This is video B on graphing polynomial functions from end behavior and zeros. In the last video, we talked about just the basic examples, and we touched on the idea of multiplicity. In these examples, we're going to incorporate multiplicity when we have multiple zeros at the same point, and kind of how that looks visually. Okay, so without further ado, here is the next example. And we're asked to sketch and graph each polynomial function given the end behavior and real zeros. So again, I have my scale ready to go, and we have zeros at -5, -1, 1, and 4. And we're told that the end behavior of this function, as x goes to positive infinity, which is out here, y goes to negative infinity down here. Okay, so for this first piece, I know my function's going to be pointing this way. For the second piece, as x goes to negative infinity, okay, that's over here. So over here, where's my function going to go? Well, it also says that y is also going to negative infinity. Whoa, down here. Okay, to negative infinity down here. So again, my function is going to be facing downwards, this direction. Okay, so what we're going to do, we'll go ahead and remind me later. We're going to sketch this graph from left to right. Okay, so I start with my end behavior. I'm going to pass through this 0. Come around, I'll pass here. Turn around, pass. And why not make this one taller? I don't know exactly what it looks like. Okay, and looks like I missed my 0. I want to go through 4. Got to go through 4. Okay, so I'm going to come down through 4, and then there's our function. Okay, so there's just a sketch of what this polynomial function could look like given our zeros and our end behavior. So this example didn't have the multiplicity. However, this example does. We're told that we have real zeros at -2, 0, and 3. And I'm going to put a different color here. I'll put blue here because I want you to pay attention to this point and what kind of happens here. So next, I'll go to the end behavior as x goes to positive infinity. That's over here. My function is going to negative infinity, so I'm going down. As x goes to negative infinity, as I go this way, my function is also again I'm going down. So that's over here. Okay, so both my end pieces are pointing down, and now I'm gonna go ahead and draw and curve through my zeros. Okay, pass through my zeros, and now I'm gonna turn around. I'm gonna approach this 0. Now pay attention, it has multiplicity. So what did we say when we have multiplicity? We said that it creates a relative max or a min, and here's kind of examples of what it looks like. So if I have multiplicity, I'm gonna touch it and I'm gonna bounce off. I'm going to touch it. I'm going to come back in the same direction. Okay, so here. Okay, so as I approach this 0, right? If there's multiplicity, okay, I'm just gonna. Man, sorry. I hope I'm not giving any of you guys vertigo, making you sick. Okay, so I touch this point and I head back in the same direction. I don't pass through it. I just kind of bounce off of it and head back down. All right. Okay, last example here. We are told that we have double multiplicity at -5 and at 4. So at -5, this is multiplicity, and at 4, we have multiplicity. Now our end behavior as x goes to positive infinity. Okay, my function is going towards positive infinity. As x goes to negative infinity, my y values are also going to positive infinity. Okay, so both of my end behaviors are going up, like this. Okay, so I'm going to approach this piece. Okay, and that's pretty poor. I can do better. I'm going to, not even touching it. Okay, how about that? And then I'm going to curve, and I'm going to come back down. I'm going to touch 4 and then head back up. Okay, so that's what multiplicity looks like. Again, you are graphing this based upon your zeros where they are. Okay, if it does not have multiplicity, you just pass through it. If it does, then you touch it and you bounce back off the same direction. You don't pass through it and into the negative or the positive quadrant. Okay, so I do have some practice problems. Here is the first one. Please pause the video, try this example, and I'll show you the answers in a second. All right, hopefully you pause the video. Here is the solutions to this practice problem. Okay, notice you have a 0 at -6. At -4, you have multiplicity. So here, right, because of this multiplicity, you just touched it and you head back the same direction. All right, and then here's another example. Please pause the video and try this one. All right, and here are the solutions. Okay, so this one we have double multiplicity, and our graph is going down. Okay, so with that, we have closure, just talking about multiplicity. Again, so what happens if we have multiplicity of a 0? Well, it's going to create a maximum or a minimum. So if I have a 0 here, here's my function, and I have multiplicity, I just touch it and I head back the same way, right? So this would be the case where we create what's called a local min. In this case, it looks like an absolute min. Or you could have the case, right, where it could be a local max. All right, so I hope you liked this video. Again, we were graphing polynomial functions from n behavior and zeros. All right, work hard, be easy. I'll catch you next time. Peace.